Welcome to The Explainer. Today we're going to talk about something you probably never see, but is absolutely critical to modern industry: GRV pipe. We're going to break down exactly what it is, how it's made, and why it's a total game changer for everything from giant chemical plants to the systems that deliver our drinking water.
Okay, so let's set the stage here. For decades, if you needed a pipe, you used metal, right? It was strong, it was the standard. But steel and iron, they have a big-time enemy: corrosion. Plus, they're incredibly heavy, a real pain to install, and in really harsh environments, they give up the ghost. The industry really needed a better solution.
And this is that better solution. GRV, which stands for glass-reinforced vinyl ester, isn't metal at all. It's a high-tech composite material. Think of it as a special blend of super strong fiberglass and a very specific type of resin, all engineered to fight off chemicals and pressure in a way that old-school materials just can't.
So let's get into the fundamentals and break down that name. You'll often see two acronyms out there: GRV and GRVE. They look almost the same, but trust me, that one extra letter, that E, makes a really big difference when it comes to performance.
So what's the deal with that E? Well, it stands for epoxy modified, and what that does is it gives the vinyl ester resin an extra shot of toughness, of resilience. It makes GRVE the heavy hitter you bring in for the absolute most demanding jobs, like, say, burying pipes in a really aggressive, corrosive soil. All right, let's peel back the layers here, literally. To really get why these pipes are so incredibly resilient, you have to look at how they're built. They aren't just one solid chunk of material. They're actually a sophisticated layered system, and each one of those layers has a critical job to do. And this is just a brilliant design. It's basically high-tech armor. First, you've got the inner liner, which is this pure resin-rich shield that protects the pipe from whatever's flowing through it. Then you've got the structural layer. This is the powerhouse, packed with glass fibers and resin for all the strength. And finally, you have an outer coat that acts like a bodyguard, protecting it from sunlight and any physical damage.
Now, you've probably heard other acronyms for composite pipes thrown around, especially GRP and GRE. They might sound kind of similar, but they have very different properties and they're used for different things. So let's have a quick composite showdown. You know, the fundamental difference between all of these boils down to just one thing: the type of resin. It's the glue that holds those glass fibers together. GRV uses vinyl ester, GRP uses a more standard polyester, and GRE uses a high-performance epoxy. That single choice in chemistry, well, it changes everything.
This table right here, this tells the whole story. You can see GRP on the low end. Yeah, it's cheaper, but its performance in temperature and strength is also the lowest. On the other end of the spectrum, you have GRE. It's the top performer, the superstar, but it also comes with a superstar price tag. And right there in the middle, that's GRV. It hits this perfect sweet spot, offering excellent chemical resistance and high strength at a much more balanced cost. For a lot of tough jobs, it's simply the best value. And this quote really just nails it. When you're in a situation where performance is absolutely non-negotiable, but the budget is still a real thing, like a desalination plant or a chemical processing line, GRV just shines as the most logical, high-value choice.
Okay, so we know what it's made of, and we know how it stacks up against the competition. But how does this advanced material go from just raw ingredients into a finished pipe? And maybe more importantly, how do you actually connect them all together on a massive job site?
The magic really happens in a process called filament winding. It sounds cool, and honestly, it is. A computer-controlled machine, a CNC machine, wraps these resin-soaked glass fibers around a spinning mold, and the exact angle of those wraps is what gives the pipe its specific strength. After it's all wound up, it gets cured with heat, cut to length, and then tested like crazy to make sure it meets really strict international standards.
And connecting these pipes out in the field is just as advanced. The method really depends on the job. For really high-pressure lines that can't move, you'd use something called a button wrap joint. For buried pipes that need a little bit of flex, the classic bell and spigot with a rubber O-ring is perfect. And to hook up to big equipment like pumps or valves, you'd use a heavy-duty flange joint for a secure, bolted connection. The whole system is built to be versatile.
So let's bring this all home. We've talked about layers and resins and winding, but what does it all mean for a real project? Why should an engineer or a project manager choose GRV? Let's tick off the main advantages.
First and foremost, and this is a huge one, durability. A properly installed GRV piping system is engineered to last for over 50 years. That's not just a pipe, that's a long-term investment in pure reliability, with very little need for maintenance.
Unlike metal, GRV just doesn't rust. It's naturally resistant to a whole bunch of chemicals, salts, and acids without needing any special coatings or anything. This makes it a perfect fit for coastal projects, chemical plants, you name it.
And here's a real game changer. Its strength-to-weight ratio is just fantastic. GRV pipe is incredibly strong, but it's only a fraction of the weight of steel. You know what that means? It means easier transport, smaller cranes, and an installation that's faster, safer, and cheaper.
So when you put all these properties together, you start to see GRV pipe everywhere, especially in critical infrastructure. We're talking about the systems that make our drinking water, the massive cooling pipes in power plants, and the complex networks inside industrial facilities. Pretty much anywhere that failure is not an option.
When you take a step back and look at the whole picture, the value here is just crystal clear. It's not about the upfront cost of the pipe. It's about the total cost of ownership over 50 years. When you factor in the easy installation, the low maintenance, and the peace of mind you get from exceptional performance.
And so we'll leave you with this thought to chew on. For the kind of projects that are meant to define our infrastructure for the next generation, how do we measure the true cost of our material choices? Is it the price tag on day one, or is it the value delivered over 50 years? Something to think about. Thanks for watching.